Hello and welcome to another episode of Slam TV. We've got a really ridiculously exciting episode for you folks at home tonight. Today we're going to be talking about probability and odds.
Woohoo! Yes!
Luckily for you folks at home, we've got a special guest with us here. He's known as the god of the gamblers. The probability he'll say something interesting, exciting, or funny is somewhere between 0 and 1. He's Professor Jay Cho.
Thank you.
How's it going, Jay?
Pretty good, pretty excited.
You're excited to be talking about probability and odds?
Uh-huh.
You're excited because probability and odds have to do with gambling?
Uh-huh.
And you're excited because you're a degenerate gambler?
Yeah, maybe.
Yeah, you're a degenerate gambler, I know you. Hey, dude, you've heard of that phrase risk versus reward before, right?
Yeah.
What does that mean to you?
Well, when I hear the term risk, I think about the probability.
Okay.
Right. So the event that is risky have very low probability because it's unlikely to happen.
What about events that are not risky?
Right. They are more likely to happen, and so they have a higher probability.
Oh, I get it. Cool. So probability, it ranges between 0 and 1, right?
Right.
And the events that are unlikely are closer to 0?
Right, and then events that are very likely to happen has probability 1.
I hear you use this word event over and over again.
Uh-huh.
What is an event?
Well, before we talk about that, we have to talk about this thing called the experiment. Probability experiment is just a procedure where the outcome depends on some sort of chance.
Okay. Can you give me an example of a probability experiment?
The easiest example might be just flipping a coin.
Right. Uh-huh.
Do you know exactly what's going to happen?
When I flip a coin,
Right.
well, the outcome's uncertain. It could be a heads or it could be a tails.
Right, so it depends on the chance, right? So that's the experiment. How about when I roll a die?
Sure, yeah. Because you don't know what the outcome of that is going to be. That also depends on chance.
Exactly.
Okay. So I think I get what a probability experiment is.
Okay.
Can you tell our viewers what an event is?
Right, event is just any particular outcome of an experiment.
Oh, so it's like the result of a probability experiment?
Exactly. When you flip a coin, what could possibly happen?
Well, it could land heads or it could land tails.
Right, so heads is an example of event, and getting tail is an example of event.
So those are each examples of events.
Exactly.
Okay, what about rolling a six-sided die?
Well, getting 1 is an event.
Or getting a 2?
Or getting a 3?
Or getting a 4?
Or getting a 5?
Or getting a 6?
Or getting a 7?
Wait, you can't roll a 7.
Technically, it can be an event.
Oh, it's still an event even though it can't happen?
Right, it's just impossible event. It's just not going to happen.
Oh, so it's a really low probability.
Yeah, indeed, it actually has probability 0.
Because
it's an impossible event.
Yes, I
know.
got it.
Unfortunately, it won't happen. Sorry.
Are there any other examples of events when rolling a six-sided die besides rolling a 1, 2, 3, 4, 5, or 6?
I can make it a little bit more complicated.
Okay.
How about an even number?
Okay.
I can label it E for even.
All right.
So even numbers have what?
2, 4, 6.
Right. So there are 3 things in it. So instead of event of even number has 2, 4, and 6 in it.
I see. Is there any other events you can think of that involve die?
Yeah, sure. Like when you're I remember playing this die game. I was like hoping for like low number.
Okay.
So it's like low number L. I can label it L. Like I was wishing for like either getting 1 or 2. That's it.
Oh, so you're going to label your event L, and that occurs when you roll a 1 or a 2.
Exactly. So that's another example of an event.
Hey, Jay, I noticed that when you were talking about these more complicated examples, you gave them letters like E and O.
Right.
But when you were talking about the previous examples, it was like 1, 2, 3, 4, 5, 6. Is there a distinction between these two types of events?
Right. We're going to call those numbers just like 1, 2, 3, just one outcome. We're going to call that a simple event.
Oh, okay.
So simple event is an event that cannot be broken down anymore.
I see. So rolling a 3, for example, is considered a simple event because you can't get any simpler than rolling a 3.
Right. Whereas getting an even number is not a simple event because even number you can break it down to 2, 4, 6.
Oh, I get it. So is it true that all events can be broken down into simple events?
Yes.
Okay. Cool. So I understand what a simple event is now. I don't understand how I can use this to help me calculate probability.
Right. Before you calculate probability, we talk about this thing called sample space.
What's the sample space?
Well, sample space is set of all simple events of an experiment.
Okay, so what would the sample space be for the coin flipping experiment?
Right, so if you look at all simple events of coin flipping, is heads or tail. So
Okay.
your sample space has tails and heads in it.
Oh, I see.
And what do you think it's going to be for rolling a die?
Well, when I roll a die,
Right.
I think the simple events are just getting a 1, a 2, a 3, a 4, a 5, or a 6.
7? No 7?
No, not a 7. So I think there's 6 things in there, 6
Right.
things in the sample space.
Right, right.
Okay, how does this help me calculate probability?
Right, so we talked about the event, we talked about the sample space, so we're going to like put them all together.
Okay,
So basically, probability is a fraction.
it's a fraction.
Fraction.
Okay, what's the denominator of the fraction?
The denominator fraction is just the number of simple events in your sample space.
Oh, okay. And what about the numerator or top of your fraction?
Top of fraction, you have the number of simple events in your event.
So you can't calculate that until you know what your event is.
Right, because when you talk about probability, you have to talk about probability of a particular event.
So I talk about the probability of getting a heads,
Right,
or the probability of rolling a 3,
exactly.
or the probability of rolling an even.
Right,
I
let's
get
try
it.
to calculate the probability of getting an even. So look at the number on the bottom. You
Okay.
have to look at the number of simple events.
All right. I think there's 6 simple events when I roll a die.
Right.
1, 2, 3, 4, 5, or 6.
Oh, you know how to count.
I do.
How about the number on the top?
I'm finding the number of simple events that result in getting an even.
Mm-hmm.
2, 4, or 6.
Good.
So then I just look at, I make a fraction out of those two. I look at the ratio. I get 3 over 6, which is
Just 1 over 2.
1 over 2, 1/2.
Exactly.
Oh, okay.
How about probability of getting a low numbers?
Well,
Let's see
if
we can
I
figure that out.
if I calculate the number of simple events in the denominator, it's still the same as our first example, right?
2, 6.
1,
yeah.
2, 3, 4, 5, or 6.
Pretty good.
The
How about-
numerator should be the number of events in L, right?
Right.
And there was 1 and 2.
That's it.
So I think the fraction should be 2 over 6, which I think reduces to 1 over 3.
Exactly.
Ah.
That's not bad, right?
I think I get it. I think I understand what you mean by the probability.
Okay. Good.
So if probability is sort of the risk part, what's the reward part, Jay?
Right. So that's basically how much you get paid.
Oh.
So let's say, for example, I'm gonna just create this game and see if you wanna play this.
Okay.
Let's say you flip a coin, right?
Right.
If you get a heads, I'm gonna give you $1.
Mm-hmm.
But if you get a tail, you lose, and you just lose your bet $1.
So if I roll a heads,
Right.
I get $1.
Uh huh.
But if I don't get a heads, I have to pay you $1.
Exactly. Do you think it's a fair game?
Sure,
Would you
that
play
seems
this?
fair. Yeah, I'd play that. Why not?
Yeah. How about the next game? It's also fair.
Okay.
When you roll a die,
Uh-huh.
if you get a 6, you win $1.
You're going to give me $1 if I roll a 6.
Exactly.
Got it.
But if you do not roll 6, you
Mhm.
basically pay me $1. It's fair, right?
Something bothers me about this.
Why? Like.
So you're
lose, you can-
saying if I win, I get $1
Exactly, by rolling a 6.
by
right?
rolling a 6.
Uh-huh.
But if I roll a 1, a 2, a 3, a 4, or a 5, I have to give you $1?
Uh-huh.
No, this doesn't seem fair at all.
It doesn't seem fair to you?
No.
Why? You lose $1, you win $1.
Explain to me how the casino pays us off.
Right. Okay, fine. I try to fool you. First, you have to talk about the odds.
Odds.
That's what I think you're trying to get into.
Okay.
All right.
So let's talk about odds. And what are
Right.
odds?
So winning odds.
Right.
First, you look at your sample space, all possible outcomes.
Mhm.
What you're going to do is you're going to group them into the winning group
Mhm.
and the losing group.
So I have all my simple events. Split them
Right.
up into 2 groups.
Exactly.
So,
So flipping a coin, right?
right.
What's in winning group?
So I flip a coin. If I want to get a heads to win, then the heads should be in the winning group.
Right. And what's in the losing group?
Tails should be in the losing group.
Right. So odds of winning is just 1-to-1. Because you have 1 in the winning group and 1 in the losing group.
Oh, so when I talk about odds, I'm really just forming a ratio.
Ratio of 2 numbers. Winning numbers and the losing numbers.
The number of winning number of simple events, and the number of losing simple events.
Exactly.
I get it.
Now look at the die game.
Which one?
That when you win when you roll 6 and you lose when you roll other numbers.
Okay.
So group them into 2 groups.
So I win when I roll a 6, so 6 should be in my winning group.
Exactly. What's in your losing group?
When I lose, I roll a 1, 2, 3, 4, a 5. So there should be 5 numbers in my losing group.
Right. So when you take a ratio of those two numbers, that gives you winning odds, which is
1 to 5.
exactly.
Ah.
So
how do I use these odds of winning to figure out what my reward will be, or how
Right.
much the casino is
So-
going to pay me?
now we're going to have to talk about this called payoff.
Payoff odds.
Odds. Right.
Payoff odds versus winning odds,
Exactly.
or odds of winning.
So if it is a fair game,
Mm-hmm.
your odds of winning and your payoff odds has to be is the reciprocal of each other.
What do you mean by reciprocal?
Reciprocal, when you have a fraction, reciprocal just means you need to flip over, you have to switch the numbers. Just
Okay.
reverse the order of the numbers.
Okay. Can we work through some examples?
Sure, so let's go back to the flipping a coin example.
Uh-huh.
So what was the winning odd again?
Flipping a coin, the odds of winning were 1 to 1.
Right, so for payoff, it should be the other way around, which is still 1 to 1. That means when you bet $1,
Mm-hmm.
you're going to have to win $1.
And that was a fair
That
game.
was fair, right?
Yeah, that was fair.
Let's look at the rolling a die game.
So
The controversial rolling a die game.
right. So I have one simple event where I win. I have 5 simple events where I lose.
Right, so odds of winning was 1 to 5.
Right. And you're saying the
So
payoff
the
odds.
fair payoff should be 5 to 1.
5 to 1. And
Then-
what odds did you offer me, Jay?
1 to 1, so I should have paid you $5 instead of $1. I am busted. Oops.
Okay, so let me just make sure that I
Right.
understand this
Okay,
right.
okay.
So what you're saying is when it comes to a fair game,
Uh-huh.
my payoff odds, if I win, I should actually get $5.
Exactly.
And if I lose, I have to pay you $1.
Exactly.
And the reason why is because the probability is much lower that I win
Right.
than I lose.
So generally speaking, if you have a low probability of winning,
Mm-hmm.
you should get paid more. And if you have high probability of winning, you should get paid less.
I think I understand this probability and odds stuff.
Right, right.
So maybe we should have a little wager, Jay. What do you
Ooh,
say?
now you're feeling big and strong.
Let's create a game to gamble on.
Sissy, let's see what to play, what to play. Okay, let's combine the flipping a coin and rolling a die all together.
Okay.
Aha. So let's say you win if you get heads and 1.
A heads and a 1. Okay.
Right. And everything else you lose.
All right.
So first we need to look at the sample space.
Right.
Let's look at all the possible outcomes.
Okay.
So you can possibly do heads and 1,
Right. Or you could do heads and 2,
or heads and 3,
or heads and 4,
heads and 5,
heads and 6,
heads and 7. Wait, no. Tails and 1,
tails and 2,
and so on and so forth.
tails and 3, tails and 4, tails and 5, and tails and 6.
So how many simple events are there?
Well, when I look at all the simple events listed out, I could see that there's 12 simple events.
Exactly.
Okay.
So we have 12 simple events to your sample space.
Mm-hmm.
Now our event has how many things in it?
Well, you have to get a 1, a heads and a 1, right?
Right.
There's only one of those.
That's it. Right.
And all the rest of them, the other 11, are losing simple events.
Right. So probability of winning is what?
Oh, well, if I want to find the probability of winning, I first have to calculate the denominator. The total number of simple events is 12.
Okay.
The numerator should be the number of simple events that result in winning, which is 1.
Right.
So my probability of winning is 1 over 12.
Right. Now let's calculate the odds of winning. It's similar, but it's different.
Okay, so there's
Yeah.
one event where I win.
Right. That's a winning group.
There's actually 11 events where I lose.
Pretty smart. Pretty smart. That's your losing group.
So my odds of winning are 1 to 11.
Right. So in order to make it a fair game, so I don't cheat you anymore.
We don't want that to happen
I
again.
know. Oops. The payoff must be what?
Well, I want to I want to find the reciprocal, which means I
Okay.
want to reverse these guys. So
Okay.
instead of 1 to 11,
Okay.
it would be 11 to 1, which
Right.
means if I were to roll a 1 and a heads, then you would have to pay me $11.
Wow.
And if I lost, I would have to give you $1.
Exactly. How about this? Instead of playing with money, because I'm kind of broke, how about we bet push-ups? You think you can do that?
I can do push-ups.
Dang, look at that. You've been working out, huh?
Yeah.
So if you roll 1 and heads and 1,
Uh-huh.
you're going to do 11 push-ups. Everything else, I'll do 1 push-up. That's
I
fair,
don't know
right?
I mean, it's a fair game. I don't know how lucky I feel. How lucky are
I
you?
feel like I can do 1 and heads. I think I can do that.
You can do
I
one.
have a power.
You want to gamble?
You want to gamble?
I want to gamble.
All right, let's do it.
Let's do it.
2, 3, 3, 3. Hey, dude. No reps. All the way. 4.